Sum and difference formulas. So until now, I've asked you for like sine of 45. And then you went to 45 on your unit circle and you took the y off, right? Or I asked you cos of 30 and you went to 30 and you took the x off, okay? Or I said tan of 30 and you take the y and divide by the x. We agree? And I could ask you 30, any reference angles of 30, 45, 60, 90, or 0, correct? Any of them that landed on the unit circle, we agree? So whenever I asked for exact values, I usually was asking for that. I was asking for you to look for the answers off the outside of the unit circle. But what happens if I ask you for something like, I don't want to do 10, let's do sine. Sine of 15. If I ask for just sine of 15, you could type into your calculator and you give me an answer, correct? But if I ask you for the exact value, we're in trouble, right? Because 15 isn't one of the arms on the unit circle, is it? So we're going to use sum and difference formulas. When asked to find exact values of angles that are not reference angles of 0 degrees, 30, 45, 60, or 90. So in this case, we have 15. It's not on the unit circle, but we can use sum and difference values. So sum, we could add something to possibly get us 15, or we could subtract something to get us 15. And in this case, we would probably subtract something to get us 15, right? Okay. So example 1. Determine the exact value exact value means what? Not decimals. So determine the exact value of sine 75. So sine 75, is there anything on the unit circle that can add together to get me 75? Yeah, 45 and 30. So we're saying sine 45 degrees plus 30 degrees. What can you not do at this point that you will try and do on your test? Distribute. Okay? So why is that the case? Well, that would give you sine 45 degrees plus sine of 30. Please type that into your calculator and give me a decimal. Sine of 45. What mode do we need to be in? Degrees. Yep. So we need to be in degree mode. And we go sine 45 plus sine 30. And we get approximately, that's why we do the little squiggle. It's approximate because we don't write the whole like the whole decimal out, right? Like it's not exact, it's approximate. 1.207106781. That should be the same answer as sine 75, should it not? Because that's technically what we did. Right? So type sine 75 in your calculator. Sine 75 is approximately 0.965925823. Are they the same? No. So can we distribute it in? No. Try this in your calculator now. Sine 45 degrees plus 30. Like literally type it like this. There's the same answer, right? So we know that these are okay. Bless you. We know that we can split it up like this. We know that it's okay to put sine 75 or sine 45 plus 30. We know that they are the same, but we do know that we cannot do this. This is not allowed. And if you're someone who's going to distribute, you need to make yourself star, 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 highlight, highlight, highlight. You need to use the formula. You cannot distribute. Okay? So we have these formulas on our formula sheet over here. We have the sum formulas, sine A plus B, sine A minus B, cos A plus B, cos A minus B, tan A plus B, tan A minus B. But what we do not have is secant, cosecant, and cotan. But what are secant, cosecant, and cotan as opposed to those ones? 1 over. Or their answers are just flipped, correct? So if I find the answer to sine and I need cosecant, I'd find the answer to sine and then I would just take the answer and I would flip it. If they asked me for secant, I would find the answer to cos and then I would just flip it. If I needed cotan of 15, I'd find the answer to that with tan and then I would flip it, okay? So there are no sine or secant, cosecant, cotan formulas, but you just find the friend's formula and flip them. All right? Okay. So we have the addition formula for sine, right? Because we have an addition sign in between. So the addition formula is sine A plus B. They have alphas and betas, it's the same thing, equals sine A cos B plus cos A sine B. So then what we need to do, and I wish they did this over there, is put them in brackets. So this is multiplied by this, and this is multiplied by this. So I always put them in brackets so that I know that I'm completely replacing them. So under this, I have sine 45 degrees plus 30. Could I have went 30 plus 45? Would that be the same as 75? I went 45 plus 30 or 30 plus 45? Yeah, same thing. Addition is fine. But what's 45 minus 30? 15. What's 30 minus 45? Negative 15. Totally different. So addition doesn't matter, but subtraction it does. Okay? So I know now that I'm going to replace every A with 45 and every B with 30. We agree? So now I'm going to get bracket sine 45, which we have an answer to on our unit circle, cos 30, which we have an answer on our unit circle, plus cos 45, which we have an answer on the unit circle, and then sine 30. Now, every single one of those is a fraction on our unit circle, is it not? So we're going to replace with 4 fractions. So go to our unit circle. Sine of 45. What's that? Root 2 over 2. It's y at 45. Cos of 30. What's that? Okay. And then, thank you. Cos of 30. Root 3 over 2. Plus cos of 45. Root 2 over 2. And sine of 30. A half. So everything up until this point has been trig. Even trig from last year, but trig from this year, correct? Everything after this is literally, can you do radicals? So most of this unit is going to be using multiplication and addition and subtraction of radicals and division of radicals by conjugates. Okay? So we're bringing back grade 11 radicals. And so often people don't make mistakes in the actual trig part, they make mistakes in their grade 11 math. So we need to make sure we're up to date with it. So when we multiply two radicals together, what do? Multiply what's in front by what's in front. So 1 times 1 is 1, so I don't need to write that. And then what's under the radical, which is called the radicand by the radicand. So root 2 times root 3 is root 6. And then 2 times 2 is 4. A lot of people put 2. I catch myself doing it the odd time because it's like just common denominator instead of multiplying it. And then what's root 2 times 1? Root 2. Because anything times 1 is itself. So my answer is root 6 plus root 2 over 4. Done. Now, what should this answer be? That's the answer to what? It's the exact value of sine 75, right? So type that into your calculator. What decimal should you get? The same decimal. Now remember, the top, the numerator has 2 terms, so it needs to go in brackets, or else your calculator is going to follow BEDMAS rules. And it's going to do this plus, and then this divided by this first. Your calculator does BEDMAS rules first. So if you don't put the numerator all in brackets, it's not going to add first. It's going to try and divide the root 2 by the 4. And when you type it in, you should get 0.96592588263, right? Same answer. That's just the exact value of it, right? So instead of sine 75, what if I had asked for cosecant 75? You just take this answer and flip it, because we literally can't do cosecant 75. There's no formula for it, correct? But we can do sine of 75. So we do sine 75 and we flip it. So we're going to get 4 over root 6 plus root 2. But what do we have to do now? Rationalize the denominator, because you can't have radicals in the denominator. So this is grade 11. How do we rationalize the denominator? Multiply by the opposite, which is called the conjugate. Someone said it. I heard it. There was a whisper. The conjugate. So what we're going to do is we're going to multiply by the exact same as the denominator, opposite sign in the middle. The reason why we do that is because when we multiply by the conjugate, the radicals go away. So we're going to multiply by root 6 minus root 2. Exact same but opposite sign. And we have to do it to the top as well. So in the top, we would get 4 root 6 minus 4 root 2. In the denominator, when we're done, we better not have any radicals. If we have radicals, we either FOILed wrong or we didn't multiply by the conjugate. So we're going to get root 6 times root 6, which is 6. When you multiply two radicals together that are the same, you get that answer. We went over this earlier this year. Because root 6 times root 6 is root 36, which is 6, right? Then we do outside. Root 2 times root 6, negative root 2, sorry, times root 6 is negative root 12. And this inside one better cancel it off. Root 2 times root 6 is positive root 12. And they cancel. That's why we multiply by the conjugate, because it'll make the two middle terms that have radicals, or at least the two terms that have radicals, opposite signs, exact same value, cancels away. And then our last one is root 2 times negative root 2, which is negative 2. And so we're going to get 4 root 6 minus 4 root 2 over 4. And then some people cross them off. But instead of crossing them off, what I would hazard you to do is actually take the GCF out of the top. So what's common to both the top two terms? A 4. So I can get 4 bracket root 6 minus root 2. And then I have a 4 in my denominator. And then I can cancel them off. Why do you have to do what? Because you have to reduce it to, why can't you just cross them off? You can, but what happens is some people will have this answer, 4 root 6 minus root 2 over 4, and then they do this, which is not allowed. This is a full term, right? Anything with a plus or minus sign, you have to be able to take something out of it in order to cancel it off. And this term here doesn't have a 4, it has a 1. So people will actually go and cross it off. So this causes them less chance of oopsieing. If you can't take the GCF out, you can't cancel it off. Okay? I'm going to get you guys to try determine the exact value of cos 15. Now, how could I make this harder? I could have asked it in the radian, which they will. So I could have asked for cos of pi over 12. Do you have to find them any differently? Is cos, what could we do to get 15? Remember, we have to use values off of our unit circle for exact values. We could do 45 minus 30. We could do 60 minus 45. We could keep going around the unit circle, right? We could do 330 minus 315. We could do anything, right? Like we could work our way around it. The bigger you get, the more angles, answers you have with negatives and positives. So a lot of people try and use the first quadrant. Okay? So you go ahead and try cos 45 minus 30 or do cos 60 minus 45. I'm going to show that both, it doesn't matter where you pick it, you're going to get the same answer. Okay? So try it out.